Okay, so now let's see the attendant problem in calculus, and it's the problem in section 12.1. Section 12.1. Okay, so we want to calculate the double integral, and we have two problems, two questions in this section. First of all, we want to calculate the double integral. So for this question, actually it's the case. Actually, it's just the pure mathematical solution equation, pure mathematical integral equation, pure mathematical integral equation. I have already given you the mathematical integral equation, so you should solve it. You want to know its double integral. And for question two, I will ask you to find the value of the solid that is bounded by some curves. And for that question, you should know what's the double integral. I mean, how to express it in terms of mathematical way. How to express it in terms of mathematical way. Yeah. So okay. So now let's see the first question. And for the first question, actually, we will when we consider this one. So now let's see the question. So for this question, you could see that if we write it down in this way, it means that we consider it's repeat integral by x firstly. So we consider it's repeat integral by x firstly, integrate by x firstly, and after that we integrate by y. So firstly we integrate by x, and after that we integrate by y. And here we have 3 terms. And integrate by x, then as we know, if we integrate by x, then we will view y as constant. So it's similar as the partial derivative situation. When we consider partial derivative, we consider its partial derivative by x, then we also view y as constant. And here it's the same. If we integrate by x for this function, if we integrate by x, then we view y as a constant. So now view y as a constant, so for the first term is constant over 1 plus 2x, so it's not difficult to solve it. This term here is x over denominator is constant, so it's also not difficult to solve it. And how about this term? Here we have x, and now y is constant, so you could view it this way. X times e is equal to 2x times some constant, so for example y equals 2. So if we want to solve this equation, you will see here we have the variable x, here we also have the variable x. So it's not very easy to solve it. Actually, we should use the integration by part. It's the skill in chapter 6. So it's not very difficult to solve it, but it's a little complicated. We could not just solve it by fundamental theorem of calculus directly, right? Okay, so now what can we do? But for this problem, x times is equal to 2xy. As you see, if we integrate by y, for this function, if we integrate by y, you will see it will be easy to solve it. The reason is that if we integrate by y, then we view x as a constant. So view x as a constant. So this question is something like the case. If we let be the 2, then it's 2 times exponential 2 times y dy. So if I ask you this question and compare with this question, this one, which one is easy to solve it? Of course this one, right? So if we want to solve this question, this problem, we will integrate by y firstly. I mean, for this term, if we want to solve this one, we will integrate by y firstly, and after that integrate x. And it means that we should interchange dx dy. So how could we use interchange dx and dy? How could we interchange dx and dy? The reason is that we have the Fubini theorem. So Fubini theorem is the most important result in this section. Even in next section, it's also the most important result. Fubini theorem. Fubini theorem, what does it mean? Fubini theorem, it means that it says that originally we have a region R. Region R is the case AB times CD. AB means that x between x A and B, x between A and B, and y between C and D. It's y. So for the function f of x, y, the A double integral. Here it means double integral. Area, it means double integral. And this one, it means g equals f of x, y. G equals f of x, y. And Fubini says that if the function is continuous, then it has a nice result. For this function f(x, y), we could integrate by x firstly, and after that integrate by y, and we also could integrate by y firstly, repeat integral, and after that integrate by x, okay. But as you see, the rectangle region, x between A and B, y between C and D. So now if we integrate by x firstly, then x between A and B, so here is AB. And y between C and D, so here is CD, right? But now if we integrate by y firstly, we interchange s and y, ds and dy. Now if we interchange y firstly, then y between C and D, we should put it here. And after that it's a function which will depend on x. Then for this function, we integrate by x and x between A and B here. So when we interchange ds and dy for the interval, upper bound and lower bound, we also need to change the bound. So for this part, you should be careful. And actually, for the result in section 12.1 and 12.2, the difference is just the bound. But for the bound, it will be complicated to solve it. It will be more complicated in section 12.2. But the difference is the bound. I mean, for the region in section 12.2, we will consider general region, not just rectangle. So for the bound, once you change the bound, the ds, interchange ds and dy, you should know how to get the upper bound, lower bound, how to change it. Okay, yeah. So now come back to this question. So as we knew, if we want to solve it, the variable x. So here we have x, so it's complicated to solve it. So we interchange ds and dy. So here is there, and for this term it's a fraction, so we rewrite it by this way: 1 plus 2x, subtract x times 1 over 1 plus 2y plus x times exponent 2xy. This one, and interchange ds dy. This one. dy. Here, dy, dx. And here, and the y, we interchange them, so for the bound, we also need to change it. Okay, so now we could solve it 10 by 10. Okay, so for the first 10, now the variable is y. The variable integrate by y firstly. Then we view x as a constant. So x is a constant. So this 10 is a constant. This 10 is a constant. This 10 is a constant. 2x is also constant. Okay. So now for the first 10, it's constant, TB. Y, its integral is y squared over 2, right? So it's y squared over 2 times the constant. The second 10, x is constant, TB. For this 10, it's integral. So we consider the easy case. 1 plus 2y, so we consider easy case 1 over y. It's integral. 1 over y is integral in natural log of y, right? Natural log of y. Okay, so they have the same form. They have the same form. I mean, it must be of the form natural log 1 plus 2y. Original, we should consider absolute value. Original, we should consider absolute value. This 10, this 10. But you know, if you consider natural log 1 plus 2y, their derivative. If you consider natural log 1 plus 2y, its derivative, what will you get? Inside, outside. So outside function is derivative is 1 over inside. Multiplied by inside function is derivative 2. Multiplied by inside function is derivative 2. Yeah. But now, we consider this one is integral. So we consider this one is integral. So you should divide by 2 in both sides. So you should divide by 2 in both sides. So actually we have this one. Natural log 1 plus 2y divided by 2, its derivative equals 1 over 1 plus 2y, this one. Right? And then now we integrate it in both sides. We integrate it in both sides. And the left hand side, for this function, consider its derivative, differentiate it firstly and after that integrate it. So fundamental theorem of calculus, we know that it's equal to itself. Natural log 1 plus 2y divided by 2, this one. And it's integral in this 10. So it's integral in this 10. I mean this 10, so it's 1 half. This one. This one. Okay. And this one is similar. I mean plus constant keep it. And exponential. So and the 2x is constant. So just constant times y. So constant times y, exponential function. Constant times y, for example 4y. What's the integral? The integral must be of the same form, right? Must have the same form. So it also must have the same form. Exponential 2xy, this form. This form. But when you consider this function is derivative, when you consider this function is derivative, differentiate by y, if you differentiate by y, what will you get? Inside function, outside function. So outside function is derivative itself. Inside function is derivative. It's 2x is constant. Right? So it's derivative 2x times this guy. But here we have the x. Right? Actually, let me see. We should divide by 2x. Yeah. Actually here if I skip, I just check these tens, this one. Okay, so this guy is derivative this one, but the integral is this guy is integral, so we should divide by 2 in both sides. So we should divide by 2 in both sides, and it's equal to x times exponential 2xy. So this function is derivative this function, this one. So and this one is exactly this one. So we integrate it bothly, simultaneous in both sides. We integrate them in both sides, so it's exactly equal to this one. So we should divide by 2. Exponential 2xy divided by 2 is what we want. It's what we want. Here. And y goes from 0 to 1. Y goes from 0 to 1. This one. This one. Okay. Yeah, so I erase it. Okay, so what's this? 0, 2. So plug in the value 1 and the 0. So it's 1 over 2, 1 half times 1 over 1 plus 2x, subtract x over 2 times natural log 1 plus 2, natural log 3 plus exponential 2x over 2, this one. Subtract the case when y equals 0. So it's 0, here is x over 2 times natural log 1 plus 0, so it's natural log 1 plus exponential 0 over 2, this one, dx, here is dx, here. And we still have another 10, the first 10 is 0, this one. And natural log 1 is also 0, so first 10 and the second 10, both of them are 0. And the third 10 exponential 0 is 1, this one, okay? Yeah. So we have this 10, the first 10, second 10, third 10, and last 10. The last 10, first one is 0, second one is 0, and here is 1 half. So just subtract 1 half. Anyway, so finally it's integral. Now integrate by x. integrate by x. So for the first term, this term is integral. So it will be similar as this one, right? It will be similar as this one. For this one, its integral must be of the form natural log of 1 plus 2x. This form. But when you consider its derivative, it's inside, it's outside. Outside function natural log is derivative to 1 over inside. Multiplied by inside function is derivative 2. So when you consider natural log its derivative is this guy multiplied by 2. So in other words, this one is integral is we should divide by 2 in both sides. We should divide by 2 in both sides. Divide by 2. Then we cancel it. And for this function it's integral. After that we integrate them simultaneously. So this term is integral equals this one. So here you should divide by 2 again. Here. This one is this one. This one is this one. It's integral in this one. And the second term, subtract natural log 3 over 2 times x is integral. X is integral is x squared. We should divide by 2. This one. Plus, here, scalar we take out 1/2 times exponential 2x. Exponential 2x is integral itself. But again, exponential 2x is derivative. Its integral must be of the form. But when you consider exponential 2x is derivative, it's equal to itself. But outside function is derivative this one. Inside function is derivative is 2. This one. So in other words, when we consider its integral, this one is integral. You should divide by 2 simultaneously. So and we cancel it. So for this function is derivative this guy. In other words, this one is integral in this one. So here we should divide by 2. We also need to divide by 2. This one is integral in this one. This one is integral in this one. And the last subtract 0, subtract 1/2. So subtract 1/2 is integral is 1/2 x. And finally, x goes from 0 to 2. This one. And I erase it and write down the final solution. So finally, 0, 2. So plug in is 1/2 is 1 over 4 times natural log. Plug in the value 2, so it's 1 plus 4, so it's natural log 5. Subtract natural log 3 over 4 times 2 squared is 4. Times 4 plus 1/2, so it's 1 over 4 times exponential to the power of 4. Subtract 1/2 times 2, so it's 1. This one. Subtract the case when x equals 0. First term is 1 over 4 times natural log of 1. Natural log 1 is 0, so first term is 0. Second term is 0. The last term is 1 over 4 times exponential 0. This one. 0 plus subtract 0. This one. And exponential 0 is 1, so it's still 1 over 4. So now let's see finally the solution is here 4 cancel it. So finally the solution is 1 over 4 natural log of 5 over 4. Natural log of 5 over 4 subtract natural log 3 plus 1 over 4 times exponential to the power of 4. Subtract 1 over 4. This one. We still have subtract 1, subtract also, so it's here is subtract 5 over 4 here. Okay, so it's the first one. It's the first question. Yeah. And now let's see second question. we want to find the value of solid as that is bounded by the parabolic curve x squared plus 2y squared plus z equals 16. And the plane x equals 2, y equals 2, and the 3 coordinate plane. 3 coordinate plane. Okay. And what do they mean? 3 coordinate plane. 3 coordinate plane, it means that we have, as we say, we have the x-axis, y-axis, z-axis, right? So x-axis is exactly, in the x-axis is yg plane, 3 coordinate plane. 3 coordinate plane, it means that x, so coordinate plane, so if it's the xy plane, so 3 coordinate plane means that it's xy plane, yg plane, and xg plane. The 3 coordinate plane in this one. But xy plane means that its g value equals 0. So xy plane also means that g equals 0. And the yg plane, in the yg plane means that s equals 0. S equals 0. And xg plane, SG plane means that y equals 0. Y equals 0. This one. So we have y equals 0, x equals 0, x equals 0, y equals 0, g equals 0. Yeah. And the question is, for this kind of question, actually, as we say, for this kind of question, first of all, you should figure out its mathematical equation. You should figure out its mathematical equation. Okay, so you should know what it means in the graph. You should know what does it mean. What does this problem say? What does this problem say? So this solid is bounded by this one, and this one, this curve. You could see that if you move it to right hand side, g equals 16 subtract x squared subtract 2y squared. This one, it's a curve. It's a parabolic curve, and for this curve, we still have another restriction. It's bounded by this curve and the plane x equals 0. So we have the plane x equals 0, x equals 2, sorry, and y equals 2. And for this question, you could compare with the question in our class. I have also told you another question here. And here is y equals 2. Here is y equals 2. Here is s equals 2. Here is s equals 2, and y equals 2, right? And s equals 0 here. S equals 0. And y equals 0. This one, y equals 0. Here, s equals 0, y equals, and g equals 0. And g equals 0 is the xy plane. X equals 0 is yg plane. S equals 0 is yg plane. And s equals 2 is also a plane. It's also a plane. So it should be of the form. And the graph probably is of the form. I could graph it. Probably is of the form. And it's the g equals 16 subtract x squared subtract 2y squared. This one. Here we have the plane x equals 2, x equals 0, y equals 2, y equals 0, and the curve g equals 16 subtract x squared subtract 2y squared. And actually, you could see that for this function, if x between 0 and 2, and y between 0 and 2, then once you consider the value, g value, at most s squared equals 4, right? At most s equals, if you want to know the value, g value is positive or negative, for this value, s squared, at most is equal to 4. And this value, at most, is equal to 2 times 2 squared. 2 squared is 4. 2 times 4 is 8. So at most is equal to 4, and it's at most is equal to 8. So at least it will be, for g value, it will be greater than or equal to 16 subtract 4 subtract 8. So it's subtract 12, so it's 4. So it will be positive. Okay, for any value, for any x and y, which is between 0 and 2, the g value is always positive. It's always positive. So it will be above the g equals 0 plane, above the xy plane, above the xy plane. Okay, yeah. Okay, anyway, so we know that it's positive. For this function, it's positive. It's positive 0, 2 times 0, 2. It's positive. So now we consider its value, the value of this solid. The value of this solid, then it's our region R, 0, 2, 0, 2. So originally the question is that it's double integral, the region R, and the function g, 16 subtract x squared subtract 2y squared, dA, area, dA, this one. It's an original problem in this one. But as we say, by Fubini, we know that it's equal to, we integrate by x firstly, and after that integrate by y, So by x is 0, 2, by y is 0, 2. So this one, we integrate by x firstly, and after that integrate by y. But you also could say that by Fubini, we also could integrate by here 16. We still have 16 subtract x squared subtract 2y squared. We could integrate by y firstly, and after integrate by x. That's fine. Yeah, it's equal to this one, and it's also equal to this one by Fubini. So you could integrate by x firstly, after that integrate by y. But you also could integrate by y firstly, and after that integrate by x. Okay, so now let's see the first one. Here, integrate by, if you integrate by x firstly, it means that inside, if we integrate by x firstly, it means that we will view y as constant. Right? So view y as constant, here is constant. So 16 is integral is 16x. Subtract x squared is this integral is x cubed, but we should divide by 3. This one. And 2y squared is constant. It's constant, so its integral is just constant times x. And x goes from 0 to 2. 0 to 2 dy. Yeah. So for this part, you should be careful. Yeah. Anyway, so you should know what it means. What it means. Repeat integral. Okay. So now just plug in the value 2 and 0. So it's 32. Subtract 2 is cube is 8. 8 over 3. Subtract 2 times 2, 4y squared. This one. Subtract 0, 0, 0, so it's subtract 0 dy. This one. And what's this? This one is 32, so it's 32y subtract 8 over 2, 3y. Subtract this one. Y squared is derivative, its integral is y cubed, but we should divide by 3. But originally we have the constant, the coefficient 4, so here. This one, and the y goes from 0 to 2. This one. And let's see what's the final solution. So final solution is here, plug in the value. So 2, 0, so it's 64. Subtract 16 over 3. Subtract 4 over 3 times 2 cubed is 8. This one. And subtract 0. And here is 4 times 8 is 32 over 3. This one. So it's 64. Subtract 16 over 3. Subtract 32 over 3. So you could combine them. So it becomes here the addition 48. But 48 divided by 3 is equal to 16. So 64 subtract 16, so it's equal to 48. So finally it's equal to 48. So finally it's equal to 48. Yeah. And for this part, you also, and as we said, you also could integrate by y firstly. Yeah. And for this part, I have also given you a solution in the solution sheet, so you could check it. But this part, I could do the first step or second step, and after that, for the solution, you could check it. Anyway, so for this one, if we integrate by y firstly, then u as constant, right? U as constant. So if you do it by this way, then what's the function? It's integral. Integrate by y. So u as constant. So it's constant. This one. Yeah. So it's 16 y subtract x squared y subtract 2y squared. 2 constant kb. Y squared is integral is y cubed. We should divide by 3. This one. And the y goes from 0 to 2 dx. And plug in the value 2 and 0 and to integrate by x and to solve it. Here is 0, 2, here is 32, subtract 2x squared, subtract 8 over 3, but we should multiply by 2, so it's 16, subtract 16 over 3, divided by 0, this one, dx, this one. 32 subtract 2x squared subtract 13, 16 divided by 3, this 10. And integrate u, finally you will get 48. Okay, yeah, so I think you could originally the problem is double integral, but by Fubini, it's equal to this one, and it's also equal to this one. And you could solve it by this way, you also could solve it by this way. But in the process, you should know the repeat integral, what does it mean. And it's similar, the concept, the concept is similar in the case when you consider partial derivative. Here, we integrate by x, then we view y as constant. If we differentiate by x, we also view y as constant to differentiate. Okay, that's all.